So this is our PPT for today. This is about phishing website detection using supervised machine learning, and this is our today's agenda. Abstract is like phishing websites are the malicious and dangerous websites. As we know, they gather our personal information and sensitive information. This will be like even if we continue, even if we continuously ban these links, still new ones will be coming out continuously. So, in order to automate this task, machine learning approach can be a better solution to solve this problem. So, we are trying to use supervised machine learning classifiers, and this is our objective. We will be like evaluating which is malicious or which is legitimate, where we'll be giving a 0 or 1, where 0 means legitimate and 1 means malicious link. As we know, these phishing websites will collect our personal information using false SMS, emails, and websites. This will be a hectic work to us to avoid. So we are using machine learning models in order to reduce manual efforts. So it will be like easily to perform or task of blocking the websites, and it will increase the efficiency. These are few papers which we have surveyed, so which we have reviewed, and this is the data set where we got from OpenML project websites and have 30 columns, and all the 30 columns have been told in the description. And the 11,151 rows are there, and where we have taken 80% of the data as the training data, and this is the methodology we have used. This is the standard and policies where we will be taking the user permission in order and some information from the user in order to tell which is malicious or which is legitimate. This is the implementation. This is the data flow diagram. We'll be gathering the data. We'll be like we'll be giving the gathered data into Excel, and we'll be giving that Excel as an input, and then we'll pre-process the data, and we'll split the data, and then we'll be like into training and testing. First we'll be giving into training, which we told earlier 80% will be the training set, and remaining will be the testing. We'll be like telling which is classification, and we'll classify the rings, and in order to tell which is malicious or which is legitimate. This is about the ER diagram, where all the links together, phishing and legitimate, will be sent as data, and this data will be stored in the Excel. We'll pre-process data, new data will be coming, and we'll apply some algorithms. We'll get the output and we'll test it. This will be the window which we'll be getting. This is the output. It will say which is phishing website, whether it is a phishing website or legitimate website. This is some of the screenshots of the demo video, which will be included. And in order to say, so as we know, spam filtering is really challenging in nowadays, because new spam links will be coming in each and every single minute. So in order to in order to reduce this, we have used some supervised machine learning, that is random forest, and random forest gave the best accuracy among all the classifiers, and this can be applicable to the smartphones using this technique in future for protecting our cell phones from phishing links. So these are the references. Thank you.
So our project is about phishing websites detection, and we are using that to machine learning to perform this task. And they have various packages used. Some of them are Pandas, NumPy, Matplotlib, and sklearn, and Seaborn. And so Matplotlib for the implementation diagrams and for the results. So we are using PyCaret module to compare the results of various algorithms on the same dataset. And I have loaded the dataset into the model. So this is a dataset, and it has around 31 columns and 11,000 rows. So first is checking if there are any null values in the dataset, and second one, if there are any null values in any column. So this is the data type of all the columns, all the features. So everything is from the integer type, and these are the various column names, and it has around 10,999 rows and 31 columns, and this is the description of the dataset. It has none of the row or column has null values, and everything is non-null, and data type is integer. So this is the dataset description. This is the count, mean, standard deviation, minimum, percentiles, and maximum. So I'm checking the various values. I mean, type of the columns, that is here minus 1 and 1 represents whether it is phishing or non-phishing. So this is the value counts. I mean, it will show the different types of descriptions of the data set, and I mean, for my one it is a legitimate and minus one it is phishing. So there are 6,157 legitimate ham websites and 4,898 phishing website links. And you can see the diagrammatic representation of the data set, and around 55% is the legitimate and 44% is the phishing. And so this is the small setup of various models, comparing the accuracy, AUC, recall precision, and F1 score and kappa score. So we are using the random forest classifier for the performance because of its bagging advantage. So it has created over sub datasets of around 10, I mean, cross validation datasets, and it will provide the accuracy, recall, score, precision, of each subset. And final is the mean and standard deviation. So I'm training. This is the correlation matrix. So you can see the correlation of various features. And I have taken 20% of the dataset for testing purpose and 80% for training purpose. And here I am selecting SVM model for its values. So it has given around 92% of the accuracy, and cross validation performance it has given a various perform. I have taken around 5 cross validation datasets, and the performance is on 91.8 to 92.3. So there isn't much deviation. And second one I have taken is KNN. So for KNN it has produced accuracy of 94%, and when I perform cross validation datasets, so it has given around 90 from 90 to 96%. So the cross validation here produces higher performance for false to lower percentage up to 90% for some others. So this model is not stable because output is less predictable, and there is a lot of deviation. And next one I have taken is random forest. So for the random forest, I have taken the reason why I have taken random forest is because of its bagging advantage, and it is much more useful for the classification techniques. And it has given around 97% accuracy. And when I have performed cross validation, their deviation is from 94 to 98%. So this is the future importance of the data set. So SS state has the much more should be given much more preference, and the right click has the least. So URL of anchor, web traffic, having supplement engines all have very much highly correlated values, and these are the top four futures with the probability with the importance greater than 0.05. So SSL state URL of anchor, web traffic, and having subdomain, and this is the plotting of the future importance. So future random forest has inbuilt feature for showing the important futures, and this is the future importance score where from 0.0 to 0.3. So next one I have used is bagging classifier, Ansible classifier for bagging. So bagging classifier is the next one, better than the not better, but it could be better than the random forest when it comes to classification. So bagging classifier has accuracy of around 94 92%. So when you have performed the cross validation on this, it has given the values from 92% to 98%. So there is a lot of deviation in it, so it can be unstable because of its unpredictable nature. So it can be avoided since there is a unpredictable nature. So the next one is logistic regression. Logistic regression. So for every model, I have taken the same training and testing size. So that is 80% is the training size and 20% is the testing size. So logistic regression, it has given person. Logistic regression has given around 91.8% to 92.4%. So it is a less accuracy compared to the remaining, such as random forest and KNN. So comparison, when I compare the models, this is the table of comparison. So SVM has the cross validation of these values from 91.8 to 92, and KNN from 90 to 96.5, and random forest 94.2 to 98.2, bagging 92.8 to 98.2, linear regression 92 to 91 to 92. So this is a description of the accuracy and the remaining factors. So here are the values. SVM has 92% accuracy and overall, and Canon has 94% overall. Rhino Forest has 97. Bagging Classfare has 96.6, and Heuristic Regression has 92.3. So this is a comparison of various models. Although every model is performing better, but still Random Forest is the highest of all. So this is the prediction performance plot. So I have taken random forest for the final model. So performing the higher model, it has the various factors to be considered. I mean, number of estimators. So the number of estimators will increase the performance, but at a point it will become at a point it will be same for everything. I mean, it will become saturated for every value, so it won't change values after at a point. So for hyperparameter tuning, I have taken various a number of estimators from 1 to 48, and that is the multiple of the 2 and up to 1000. So when I perform the I have checked the graph performance. So I have taken so this is the performance plot of various classifier algorithms. So when I'm executing this, um, so this is the AUC graph, and we can see there is a peak value here. So I have built a random forest classifier on the number of estimators as this value. So I have taken 32 estimators, and with that the random forest accuracy is for 97%, and this is the confusion matrix. There are 42.36% true positives and 1.91 false positive and 1% true negative and 54.73% false negative values. So and this is the values that are wrongly predicted values. So when it comes to final model, I have taken a random forest classifier with the same values, and the mean square error value is down 1.6%. Sorry, 1.16%. So we can see there the decision boundary. This is the correctly classified values, and this is the correctly classified values, and these both are wrongly classified. So here I am testing the model with a input customized input. So with that for that I have got correct value. So the true positive values are 932 and true negatives are 1203. False positives are 42, false negatives are 22. So this is the future importance. Uh, Finally the matrix, and when the test size is 2136 values out of that, so the test size is 2200, and out of that 2136 values are classified correctly, and 64 values are classified incorrectly, and that's a 97% is correctly classified values, and 3% incorrectly, and record score is 98.2%, and precision score is 96.6%, and advanced score 97.4%. And this is how the model learns from the mistakes, and this is the false posture on x-axis and true posture on y-axis. So this is how the model learns. So I have created a GUI for the prediction, so it will be easy for while checking. So it has the 30 values, and it will show whether it is a phishing website or legitimate website. So for example, I'm giving a sample one. So if it is given everything as legitimate, and it should show it as legitimate. Yeah, it is legitimate. So this is how we can show the result here. So this is the code for the GUI, and so the real data set is data set size is 11,000 rows, 11,350 rows, and out of that I have taken 50 rows for testing apart from the data set. So I have tested that, and I got 94% accuracy. So there are only three values wrongly classified. So that's it for the project. Thank you.